everybody. Here we are again, and well, I got to tell you that this section we're going to be studying is called nomenclature, and you can sound really smart when you talk to your guy friends and tell them that nomenclature is what you're studying. And basically, it's a term that applies to either a list of names or a system of procedures or a way to name certain things. And thank goodness we have such a system, because if not, it would be kind of crazy to be able to name chemicals, because there are so many of them that it would be very, very difficult to remember them all. But there's a system, and we can apply that system to all compounds of a certain type. Okay, so this here is a picture of the place where this organization I'm going to tell you about, the place where it's located. It's the IUPAC, UPAC, and it's the International Union of Pure and Applied Chemistry. And basically, this is a group of scientists. It's a group that represents chemists around the world. And it's located in Switzerland, in Zurich. And I thought you might like to see a picture. I love to travel, and I would love to be able to see this place. It looks gorgeous right there in the waterway. It's just a cool place. So maybe someday I'll be able to visit. All right, so we're going to talk about why nomenclature. And I mentioned it a little bit ago, and the reason is that we have to have some system of organization, because if not, we're going to have to remember every single name. For example, H2O is water, and that's the name of it, and NH3 is ammonia, and that is the name of the stuff that is in your window cleaners. But the thing is that it's too hard to remember specific names like that. So there is a system that we use to name compounds. And here we go. All right, so a quick review about ionic compounds. Cations and anions make ionic compounds. Remember that every ionic compound has a cation and an anion, or possibly a polyatomic ion. But we'll discuss that later. The cation is the positive ion, and the anion is the negative ion. And it is they are found in that order. Always the cation is first. That's the metal. Metals tend to lose electrons, therefore they form positive ions. We've already discussed all of this. And an anion is negative, and they tend to gain electrons, so therefore they become negative ions. Metal, it's a metal and a nonmetal. And remember that they are crystals. They are stacked up. The ions stack up, and these beautiful crystals form. And we have also discussed this before. Now, take a look at this little slide. Give you a moment to read. This reminds me of Jesuit. And I think the girls just came to the window and are visiting the fellows at Jesuit. The little fellows that are being attracted to the window, and the girls are being attracted as well. The positive attracting the negative. So it reminds me of Jesuit and Academy. It looks like the girls went to visit Jesuit. So now we're going to prepare for nomenclature. A quick review of ions. Ions are charged atoms. A positive and a negative ion come together to form an ionic compound. Positive and a negative. The polyatomic ions are ones that we're going to be discussing a little later, but for right now, we're concerned about monatomic ions. And monatomic ions are simply ions made up of only one atom. Examples are, monatomic ions are Na, and I got to get some practice. Oops, okay. I got to get practice writing these and working with the pen. Oops, I'm not doing something right here. Okay, I'll come back to it and try again. Okay, Na. Now it's not writing. Okay, I got to pick up the pen again and pick up maybe a color. Okay, and we're going to do Na. Okay, that's better. Ion. And another one is Cl minus ion. And we can talk about K plus. And we can talk about O minus 2. And of course, this is the sodium ion and the potassium ion. And remember, they are named the same as the atom name. And then we have the chloride ion. We change the root to an IDE ending. IDE ending. Chloride ion and oxide ion. So another IDE ending. All right. And that's that. There are many monatomic ions. Okay, so a quick reminder of what we already did, and we can predict the charges of these ions by simply looking at the periodic table. And we know that the alkaline earth metals form +1 ions, and we know that the alkaline, I'm sorry, I messed up. The alkali metals are form +1s. The alkaline earth metals form +2. And then we come over here and we know that this boron family forms +3, and this family forms +4 or -4. Okay. And so these either lose or gain electrons. And these right here are the nitrogen family, -3, -2, and -1. And these guys up here are 0 in charge because they do not form compounds. All right, so remembering that and being able to check, we can start writing, pretty soon, writing binary compounds made up of 2 elements, a metal and a nonmetal. It could be a nonmetal and a nonmetal, but right now we're going to discard that. We're not going to worry about these right now because these are another type of compound. And right now we're worried about writing compounds that are ionic. So we are not going to be concerned with those at the moment. All right, so here we are, type 1s, which is our goal for today. The metal forms only one type of cation. So that means that we have to go to the periodic table, and it's all the elements excluding transitions. Remember, transition metals vary in charge. So transition metals, got to get practice with this pen. It's not easy to do. Vary. Okay, vary in charge. All right. But the other ones, for the most part, they don't. And they can vary, but for the most part, they don't. So type 1s involve metals that form only one type of cation. In other words, for the most part, they will not be transition metals. Let's have an example. Ca, the charge is 2+. So first we write the symbol and then its charge. And then we can write the negative ion, Cl minus, and that is, we're going to crisscross, and this comes down here. So this becomes a 2, and this, sorry, this becomes a 1, I messed up there, and this becomes a 2, too worried about the pen. So it is going to be CaCl2, and that's my compound. We can try another one. We can say K Br, and K is a positive and bromide is a negative, and since they cancel each other out, the compound is just KBr. Okay, all right, that works. All right, so the rules for writing the formulas is you write the cation first, and then we write the charges, we crisscross, we verify that it's neutral or add numbers, and we remove the charges. And we have our compound. All right, so now we're going to talk about naming. You have already done the writing of the compounds, but we're going to talk about naming. And the naming is pretty simple. The cation always is named as the element, the same way as the element. And the anion uses the root of the atom, and then we had a suffix IDE. So the name of this compound is going to be, first of all, the cation, magnesium, wow, it's really difficult to write with this pen, and I'm too worried and I'm messing up here. Okay, magnesium, this is a U and an M, and then the second part is bromide. Bromide. Maybe this is easier if I write this way. I think it might be a little easier. And then here we have calcium. Calcium chloride. I'm not getting better. I'm getting worse at this. Ha! Oh, we'll practice. We'll practice. I promise there'll be plenty of practice. All right. And finally, tomorrow we're going to practice naming more compounds, and you will become a pro at this. And that's really cool. All right. Have a nice evening, and I'll see you in class tomorrow.